All right, so first thing in today's video, we need to talk about mole and mass ratios based on the empirical formula. So if we need a mole ratio, all we have to do is look at the subscripts in the formula. So for example, if we are looking for the mole ratio in CH2, it is literally 1 to 2. So 1 mole of carbon to 2 moles of hydrogen. So just from the empirical formula, 1C, 2 H's, so 1 to 2 mole ratio. Mass ratio would be just a smidgen harder. So again, if we have CH2, we have to think about if we have 1 mole of C, that would be 12 grams, and 2 moles of hydrogen would be 2 grams. So they would be in a 6-to-1 mass ratio. So I just wanted to point out that mole ratio and mass ratio are not going to be the same, even for the same formula. Mole ratio would be simply just the subscripts. Mass ratio, you have to take into account the gram formula masses. And our last slide just refreshes our memory on conservation of the mass. So if we have a reaction and you know everything but one variable from the reaction, you can figure out the missing mass using conservation of mass. So in this example here, we have 103 grams of potassium chlorate is decomposed to make 62.7 grams of potassium chloride and an unknown amount of oxygen gas. So here's our equation. All right, so we start with 103 grams of potassium chlorate. Conservation of mass says our mass before the reaction must be equal to the mass after the reaction. So if the KCl is 62.7 grams, then oxygen would just be my missing mass, and I can just subtract in order to figure that out. So that would give me 40.3 grams. So we can just use conservation of mass if we know all but one substance. If we were missing multiple substances, then we would need to do a longer mole calculation in order to figure out the missing mass, and that is actually going to be the topic of our next video.